Welcome
to the joy of coding.
Hello, and welcome to episode 302 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. If you're a frequent watcher of the stream, welcome back. If this is your first time, welcome. I hope this is what you were hoping it was. Let me start by sharing my screen. Okay, it is October 12th, 2022, episode 302, and a reminder, no plan survives breakfast. I think I know what I'm going to be doing today. I think I know what I'm going to be hacking on, but none of what I'm doing has been like pre-written or pre-planned in advance beyond just kind of having a vague sense of what I want to do. So, you know, we might get stuck, we might get sidelined, things might go wrong. That's okay. That's the whole point of this, is to just watch me get in and out of trouble. That's the first thing. The second thing is that the agenda that we're looking at is available to you. If you're watching this on Air Mozilla, check out the video description section. And if you're watching YouTube, check out the details section. Same goes with Diode. I think there's a details section. And if you're watching this on Twitch, there are actually links now in, like, I think underneath. Someone on Twitch, if you're watching this on Twitch, hopefully if you're watching this, there's like some links at the bottom now. I thought I figured out how to do that. One should be like the agenda and the rate this episode link. If you can't find it, let me know and I'll drop them in the chat. But I tried to make that work because that way I don't have to keep dropping stuff into the chat like I've been doing for literally years. So a first for me. Okay, the second thing is that you should be aware that there is an episode guide linked here from the agenda. The agenda will, by the way, update as I edit it. It will synchronize and if you refresh the page, you'll see my changes over time. And the links in here for the episode guide might be helpful if you're curious to know, what's gone on in previous episodes. If you want to, if you're watching this in the future and want to know what happened during this episode, presumably the episode guide will have sort of a take on what happened during this episode, and you can read up on that. And if you feel like contributing to the episode guide, because it's completely viewer driven, go ahead and send me a pull request to the repository. It's hosted on GitHub. You can not only add your own notes, addenda, corrections, you can add commentary about things that I did. Maybe you want to sort of show another angle of something I did, or talk about a different, alternative, I don't know. Basically, I'm pretty liberal with what I accept to the episode guide, so go ahead and send me a pull request. And if you're not sure what a pull request is or what contributing to the episode guide is like, follow the links because there's a contributing guide and some links here about creating pull requests. So there you go. So what do I want to work on today? It's the same thing we've been doing for a couple of weeks now, modulo those few weeks in September, which is we're trying to move a bunch of code from the Windows jump list mechanism that we have in Firefox off of the main thread. So we've already done a bunch of that. We had this kind of like shopping list. We got to here last time. We really haven't done a whole lot of manual testing. It's been a lot of like just kind of like rejigging, a lot of boilerplate to make things return promises and farm work off to a separate thread. But we're almost through it. I think if we're lucky, we might actually be able to write tests, or not write tests. This is actually a very tricky thing to test because it touches the operating system mechanisms, and our testing infrastructure isn't really set up for it. So we might have to just do a bunch of manual testing here, which is a little unfortunate, but hey, that's the world we live in. But we are going to want to like update a bunch of the callers to the above methods. And once we move a bunch of the stuff off of the main thread, like we have to remember why we're doing all of this, is that, the Windows jump list stuff, by working on the main thread and being designed to be, for the most part, some of it's off main thread, but some of it's on the main thread, and it deals with like lock contention. Well, anytime you've got work that's sometimes happening off of the main thread and sometimes on the main thread, you have to do like synchronization with mutexes or locks or something. And that's causing like jank in the browser. Like users are experiencing responsiveness issues, and we can tell that because our BHR report, our background hang reports, you can see, our hang stats rather, show the, let's pull up a recent hang stat. So from October 7th, I'm reasonably certain we're going to find that the jump list stuff is still in like the top 5. Yeah, it's number 4. Jump list, still doing main thread IO. And so like there is some work to do here. By moving all this stuff off of the main thread, we can alleviate some of that jank, and that's good. And that also means, because there was a lot of effort to make that jank occur at like infrequently, and maybe when the user is idle or away from their computer, we can remove a lot of that complexity as soon as we move it off of the main thread. So this is like the beginnings of really improving, I think, this part of the code base, where we can simplify it after we get it fully off of the main thread. So that's the idea. Let's get into it. I want to do a special shout out. Alecadd is in here, ALECADDD, who is a prolific contributor to Thunderbird, reviewed my patch for the address book a few weeks back, and I want to thank him for that. And he's in the Matrix chat, so you should check out his stream. I think I have a link to it in the agenda. If you scroll down to Alessandro Castellani, I hope I'm pronouncing that correctly. You should follow this link and watch Alessandro hack on Thunderbird. This is where you go. He's got a YouTube channel, very fancy, very well produced. Not like my sort of warts and all approach. He knows what he's doing. All right, so let's keep going. I have not done anything since we were last working on this, so we are picking up right where we left off. We had just moved set app user model ID off of the main thread, so let's take a quick peek at that. Right, that's inside of jump list builder, not WinTaskbar. We also, we had to update a caller of set app user model ID outside of the builder. The jump list builder is where most of the activity is happening, and we had to update a caller to accept a promise. Now, thankfully, it looks like the create jump list builder, it seems that it's all right that that we just kind of like throw away whatever happens to this promise. We just like throw it away, and I hope that's okay. That's what we went with last time. Like the interface expects us to get a promise out of it, and then because the original caller didn't seem to care what happened, we just throw away the promise. So let's keep going. The next one was add list to build. Now, before we do this, I actually want to check to see what else is calling add list to build, because I don't want to be surprised by another spot where like a C++, a native caller is calling into it, and we have to like change a bunch of stuff. That's what happened last time. And it looks like it's mainly just script callers. I think some tests here. This is all boilerplate to define, add list to build. Here it's being called by script. And then there's just like a bunch of generated code. We can ignore that. So that's good. Add list to build is just called by script. So it should be relatively straightforward to update that. Let's start by going to the IDL file and add list to build. Whoops, I'm in the wrong IDL file. It's jump list builder. This is the one we're talking about. So it accepts a couple of arguments here. It accepts a category type. I guess that's maybe it's a short, and then an array of jump list items, and then a category name string, presumably for custom lists. And then it returns true if the operation completed successfully. I think what we're going to be doing is basically what we've been doing elsewhere, which is we're going to make this return, instead of a Boolean, we're going to make it return a promise that will resolve or reject. And it'll resolve if the operation completes successfully, and it will reject if any of these things occur. And we're going to need to update all this documentation at some point. I'm looking through some of the chat here. There's some Shershak Alakad interaction. That's great. Smurf D notes that I missed a good opportunity to say jump right in. Oh, I like it. I like it. Jump right in.
Here we go!
And Alex, you're an internet celebrity for real. I'm happy that he's in the chat, checking things out. You're right, Smurf D. I should be like focusing on the puns. So add list to build. We're updating the IDL. That's done. Now let's go update the actual implementation. So thankfully the header file will be updated by all of the IDL boilerplate stuff. It's really the C++ that we want to update here. Let's take a quick look at what it does. So here we're accepting our arguments. We default the return value to being false, and then here we take our lock. This is the sort of thing we're trying to avoid, is like taking the locks. This is where you can block the main thread. If like another thread has the lock and it hasn't given it up yet. And then we get access to the jump list manager, and then we switch through the category type and we see what kind of jump list we're creating. Are we creating tasks? If so, we do all of these things and we go through the items in the list. Okay. One thing I'm not entirely certain of is whether or not we can move an NSI array easily between threads. Probably we can. I'm just curious to know if there are any other examples of us doing that. I don't know if they're designed to have that happen to them. NSI arrays are just like, this is like old school array stuff. XPCOM style. And I think we've done something recently with by passing a collection of some kind. Where was it? Is that a no? Am I wrong? Is available init list build, add list to build, abort, callback. Okay, and then so we don't have any prior examples of moving an NSI array. Let's do a quick check though, because I'll bet you we can, if possible, we might be able to find some examples. I'm going to show you how I do that. So I'm going to look through our IDL files, I'm looking for things that return promises, and then I'm going to search this page for NSI array. Okay, so see, we will accept arrays of certain things, but not arrays of like components, like like XPCOM components. So I'm starting to get a little worried that we might be getting ourselves into trouble here. Like, I will bet you that we will be able to move this like array of AC strings off of the main thread. Presumably that's what this does. Is like it will take your array and yeah, it just like, oh, it clones it. It clones the array and then does stuff with it in a different thread. So I'm already gonna, here's my prediction. This episode's gonna be all about figuring out whether or not we can, what's the right way of moving an XPCOM array such that it is no longer on the main thread. So it's contents, and it might mean copying them. It's been a while since I've had to deal directly with NSI arrays, but I feel like what I'm describing is the sort of thing that other people will have dealt with. So what I'm hunting around for is transferable. See, that sounds like something. Oh, invoke drag session transferables. when I see the word transferable, it makes me think, oh, you're going to move that off to a different thread. But I actually don't think that that happens with drag. Classic, that's what we're talking about. Also, like, so we're clear, do the items need to be an NSI array? It's an array of NSI jump list items. And what is an NSI jump list item? An NSI jump list item it's reasonable to use for jump list item. It's a very thin wrapper around a type. And then these things inherit from it. Okay. Okay. And how did this all worked? Maybe this is why this had to be on the main thread, is because we were working with these like NSI jump list items, these XPCOM things. And because that was the way it was designed, we are having a hard time moving this, which I think is the place where things like go wrong for us. Sorry, I'm looking at the wrong thing. I should be looking at not init list build. It's here, add list to build. I suspect this is where we see most of our blocking. So what do we do with these items? We construct an NSI object collection. Well, presuming it's a series of tasks, and then we figure out whether or not it's a separator. We basically convert them into something else. We convert them into an NSI object collection. And this is almost certainly some kind of like Win32 structure, like COM, Microsoft COM thing. An object collection. And then an object array. Otherwise, so we if we've got a list of items or a list of category tasks, I'm just blurring my eyes here over the details, but we effectively create, we translate these into like COM arrays and objects, MSCOM. If they're category recent, then we call append known category. If it's frequent, we append a known category. If it's a custom list, we yet again create an object collection. And a P array. Are those things thread safe? Like, how easy is it to move an NSI object collection off of the main thread? Are these like, what are these things? MSCOM. Microsoft Learn extends the island of my friends where the interface has 3 types, 3 methods. Move on. When to use. Use this interface. Is it object array? When to implement. It doesn't say anything about thread safety, so or like transferring. Enumerable object collection. Okay. Let's just quickly see here. Background thread. Foreground, background threads. PowerShell test jump list. Ooh. This is Microsoft code. This is how they do it. Okay. This is how they commit lists. What thread does this run on? New thread, create elevated entry. Comp threading with this. Creating jump is not critical. Okay. So create elevated entry. Okay. So you can create one of these things in a different thread. This is happening in this other thread. There's an example of that happening. Can you transfer them between threads? Or, let's go back and look at this for a second here. What are we actually doing here? We are constructing a list. Well, how does this translation occur? We figure out how many items. We go through the list of jump list items. We figure out if it's a separator, and if so, we pull out. Oh boy, okay. Get shell link, and then you pass it an IO thread. Shell link. What does that do? Get shell link jump list shortcut. What is that? What is jump list shortcut get shell link? Okay, so you pass it a thread, and then what? What are you doing with your IO thread? What are you doing? What do you do anything with this IO thread? Okay, here we go. We're just saying, oh, go and get a cached icon file. Okay, off of the main thread. So we try and do a little bit of disk IO off of the main thread. Okay. And then cache it, probably. Okay. And who is calling? Like jump list builder. Add list to build. How does this work? It's like, hey, here's a bunch of items. We're going to create this mutable array, and then we're going to create a handler app item. And the way it works is we create an instance of jump list shortcut, and we give it the app, the icon index, and the favicon page URI. And I wonder if this is our mistake of like exposing this structure. Like maybe we can describe, like we're actually creating, when we create a jump list shortcut, if we go into here, jump list item. When we create one of these things, I think we actually end up creating the underlying com thinger, right? Equals, get separator. Like sometimes we'll like create shell links, creates a shell link that encapsulates a shortcut. So a lot of setters, getters. We check to see if things are equal. That doesn't require us to create any com stuff, like MS-com stuff, and then comparing the hashes. But when we ultimately get these things, get separator, it's almost like this is a, you know, it's a helper that allows us to, you know, when we set all these properties and then we say, okay, now give me the com separator, and it will pull out, yeah, I shell link W or get shell link. Get jump list shortcut. And this is the other way around. We're gonna convert a shell link to a NSI jump list shortcut. Okay. So I'm starting to think that we have a problem here. You know, we had this grand plan. Thanks for the love and good vibes. We had this grand plan. Oh, we'll just make everything return a promise, move things off of the main thread, everything's great. However, we have hit a snag. And maybe this is my fault, because this is my fault. I should have done a more thorough examination of how this stuff worked before I started moving stuff off. But basically, it's like, okay, this interface is a very thin layer on top of basically the Win32 API, and we're making the front end responsible for constructing these things that I don't think transfer nicely to other threads. I mean, maybe I'm wrong about that. Maybe I'm making a bad assumption, but I'm worried that some of these things are not safe to transfer across threads. To sort of like move them. That sounds like a great way of getting subtle subtle bugs and crashes and stuff. Vinitkami, yes, I moved away from Evernote a while back. I'm using something called Joplin. I'm much happier with it. So let's take some notes here. This is what I like to do whenever I am working on something a little trickier. We're going to take some notes. And what I want to start with is an explanation of the problem. So I started to migrate all of these methods inside of NSI jump list builder off of the main thread using promises, and everything was going great. Until I reached, what was it called? Add list to build. Here, I'm going to use the markdown editor. Until I reached add list to build, which takes NSI jump list items. It takes an NSI array of NSI jump list items as an argument. I am not confident that we can move these things off of the main thread safely. In fact, I suspect that this is why the code wasn't more fully moved off of the main thread when this was last looked at. This is a larger architectural problem. The callers have direct responsibility for creating these NSI jump list items, And those NSI jump list items are then generate MSCOM goop, which gets passed to the Win32 methods that ultimately populate the jump list. So what do we want to do here? Is it useful for the JavaScript to have access to the NSI jump list items? If not, can we make it so that there's a simpler way of describing what will eventually become a jump list item? In such, and that simpler way is easily transferred between threads, easily and safely transferred between, moved between threads to create the COM goop. So let's actually take a quick peek inside of Windows jump list. The JSM, the JavaScript that's actually using it, and see if we can get a better sense of how it's being used. Because yeah, I think I'm starting to get this flavor here that we're exposing far too much detail to the JavaScript. Far too much. It's basically, we've got this very thin layer that's giving the JavaScript almost direct access to the Win32 APIs that populate the jump list. And it doesn't need to be that direct. That's also why it's so, like, this feels so clumsy. You have a builder, and you have the items, and then you build the list, and then you commit the list. Like, all of this feels very, like inherited complexity, because we're basically mapping the old MSCOM API, the Win32 API for jump lists, into what we're exposing to JavaScript. And we don't have to do that. Like, we could make it better for ourselves at least, and then try and abstract away some of the awkwardness of that API. So how does it use it? Let's go right to the very beginning again. I apologize. I thought we were going to be trucking along, but I think we're going to have to do some re-examining, some navel gazing. Like when we construct a task, we store these task lists. Tasks. We build the tasks. That's when we create, jump list item creation helpers. We get the local handler app, a local handler app instance, and say executable equals file. Get the append argument parameter args, and then we pass handler app to item app. Like, these are just, that's a string, that's a number. This is the tricky part. Handler app. What is that? That is a local handler app. URI loader. What is this? From MIME info. What are we doing in here? As a local OS level executable. It points to the executable. There's a number of parameters. We can append parameters. We can get them and see if they exist. So basically, this this wraps a way of describing how to call an executable and what arguments to pass it. Parameters, I guess, not arguments. I don't know what the difference is. And let's see how that's passed to the MS-COM stuff. So like our jump list item, whenever you set the app, set app, we say, okay, we'll just have a pointer to it, and then we do use it to see whether or not we get a local handler app. We see whether or not, I guess they can be equivalent. That's all we use it for. How do we pass this along when we get the shell link? Get the type, shortcut. Here, we get the handler app. Shortcut. Static. Oh, I see. This is a static one. Shortcut. We query interface for a jump list shortcut. We get the handler app. We retrieve the path, title, description, and optional command line arguments. We pull all those out. And then we create this thing called a property store. No, hold on. What's a PSL? PSL is, what is PSL? It's an iShell link. And where did we create? Oh, here, we created it here. And we say, hey, here's a string. That's the path to our app. Here's our description. Here's some arguments. So ultimately, all of that was to produce some strings. And those we can serialize over. Someone's pointing at an example. It's SmurfD coming at us with a jump list customization example. Ooh, for JavaScript. Jump list solution. Sample configuration. Scenario 1. Let's see. Not helpful. Okay, so what do we know so far? So the NSI local app handler is really just used to construct the string needed by the iShell link to, run the local executable, aka Firefox, with some arguments. In theory, it should be straightforward to pull those strings out on the main thread and move them over to a background thread. Nice. Okay, what else have we learned? Let's keep going. Like when we construct that, and then it's the icon index and it's the favicon on page URI. Now there was other stuff too, like there's the handler app item, but then you can also you're gonna create other things. Get handler app item. There's another thing that we'll create as well. This is wild stuff. So, do we ever create a separator? No, we just create the one shortcut. Separator. When taskbar. Is this thing create a separator? What creates the separator? NSI. Jump list item.idl. What creates the nothing needed here? What are you talking about? What is this thing? Jump list separator. Who uses it? Nobody. Nobody uses it. But you can create one. Oh, we do have some tests. That's interesting. So we can create a jump list item, a separator, a shortcut, or a link. What's the difference between a shortcut and a link? Jump list link, a URI link jump list item, and a shortcut, a generic application shortcut with command lines. Oh, I see. One of these will be like, hey, you're going to a web page. One of these is like, hey, this is just like you can call into any other application, probably yourself. Okay. Jump list link. And of these, I think this test is actually really helpful. Like, what's actually used? Does anyone actually ever create a separator? The answer, no. That can go away. We can get rid of that. We don't seem to need it. Jump list item. Almost certainly this is used. In just a test. So, I don't know what that means. An SI jump list item is also just like the base class. It's back in 2009. I think it's fair to say that we didn't end up adding more stuff. And then shortcut. Who uses shortcut? We use it in the front end. Yes, very good. And then link. Link, listen. We don't use it. We don't use it. We just use jump list shortcut. What was jump list link used for? Jump list link. Like, you'd create it, and like what? A jump list item, jump list link. Ultimately, what did it create under the hood? Jump list link. Jump list item base, link. Jump list link. We compare some hashes, and then a shortcut, and then you can see whether or not they're equal, and then a separator, and then you get a shell link to encapsulate a shortcut to local apps, and you pass it any kind of item, and you get the type. If it's a shortcut, I see. Is it a shortcut? It's got to be a shortcut. Then we'll get a shell link. Wait. Jump list shortcut. Get shell link. Jumps as static. Get shell link. That's going to get out a shell. Shell link. And then over here, get jump list shortcut. is going to do the other direction. And then get shell item. Do we ever actually use this stuff? For a given I shall M create return populated NSI jump list link. I don't think we do. Oh, maybe. But only if it's a jump list item link. And I think we only use shortcuts. Gang, I think we're starting to notice a pattern here. There's some old vestigial stuff. I think hypothesis. Hypothesis time. Hypothesis. Hypothesis. We only ever use NSI jump list shortcut. We never use NSI jump list link or NSI jump list separator. Like, we have the support for it, but I don't think we ever used it. I don't think we ever created one. So whenever, let's look at some of the history here. Jump list platform support. When this got added, back in 2009, jump list feature. Add Firefox support. Then browser glue. What did they do? They're like, hey, okay, get jumplist.jsm. Here's the checked in patch. Originally, jumplist.jsm would jump list link, jump list item, Mozilla taskbar service, create an array, build tasks. We create handler app item. All use get handler app item, which just used jump list shortcut. We did have something called get separator item. We never used link. We never used get. Okay, so it looks like the original landing had support for using the separator, but never used NSI jump list link. Jump list separator. So it was like get separator item, but nothing actually called it. And never used jump list link. Okay, the original landing. Let's link to that. Okay. This is fascinating stuff, gang. So let's imagine a better world. In a world, what does this thing actually do? We got all this description of stuff. We've got all this goop that allows it to like talk to the Win32 stuff. But what does it actually do? I think that's the real question. I think what happens is that on startup, we create a default list. Or rather, we construct all of like our goop, all of the stuff that we need. We get our prefs, and then we call update timer and create a timer that every time refresh in seconds, number of seconds goes by, not precisely, with some slack. So every 120 seconds, every 2 minutes, we'll call. Oh, we'll wait for idle activity. And then as soon as we have some idle activity, we'll send a low priority event to update. And what update does is it constructs our list that we want and then commits it. That's all this thing does. And there are some caveats, right? Like we need to observe if like your place's database changes, you know, you if we're shutting down or if you clear your history, we need to update stuff. But otherwise, this is all just like a lot of goop to do what I just described. And so let's write that down. So so what happens, essentially, this thing waits, this thing updates the jump list every 2 minutes and jumps through a lot of hoops, through a lot of hoops to avoid blocking the main thread when it's under load from user activity. It's an under load in general. But because it will block the main thread. Lots of heroics, but ultimately this is symptomatic of the original implementation that exposed too much detail of the underlying MS-COM stuff, MS-COM Win32 taskbar stuff. No shade on the original implementer, Jim Matthews. If you're watching this, no shade whatsoever. You got Windows jump lists working. It's just now that we've got all this hindsight, and we know, for example, because like when this was being built, 2009. When did Windows 7 come out? Windows 7 release date. October 22nd, 2009. So like we were working on this when Windows 7 was either just about to come out or had just come out. I don't exactly know what the timing is there. But like at that point, you know, things are still fluid. And at this point, jump lists are like, they've been around for a while. It's Microsoft, which means that the API is not going to change much. So it's stable. Whereas you can see that there was some like uncertainty in how we implemented it. Like if you look at the IDL file again, it's like, okay, well, if we ever need to add new kinds, because maybe they're going to have different kinds, we'll just add to this list or whatever, right? Like, yeah. Okay, so let's imagine a better world. Every 2 minutes is fine. We can probably avoid a lot of the use idle time, low priority events by simply using a low priority background thread to do all of the MS-COM stuff. This is basically what we were trying to do before. But what we need to do is design a new API so that the front end doesn't actually have to manipulate NSI jump list items. Yeah, SmurfD points out that the documentation for the jump list stuff maybe wasn't as good in 2009 as it is today. Yeah, it's possible. It's very possible. Okay, so what would that look like? What's the easiest way to pass structures across, like, like between threads? Like it's like serialization, deserialization. I feel like, I mean, there's lots of prior art of doing that. I'm not the first to try and move things between threads. I've got to find what the appropriate thing to do is. And where would be a good place to look for examples? Probably more recent changes to DOM. What does stuff off of the main thread? Let's take a look at Firefox release notes. Let's take a look. I'm doing this for a reason. Let's take a look at things that have changed in the web platform. Off-screen canvas API. That's definitely going to be off of the main thread. What do? How do you use it? Create a new one. You get these objects that you can like post message. You post message to it. Worker. Canvas, you get the transfer control to off screen. You get this thing that's transferable. Okay. Transfer control to off screen. You're creating an off-screen canvas. An off-screen canvas. Oops. This is probably, I think I'm barking up the wrong tree here. This is, I think, far more complicated than what I'm really interested in. Canvas runner context helper. This is a helper class for transferring to a worker thread. Because off-screen canvas is not thread safe, so we cannot pass off-screen canvas to worker thread directly. Thus, we create a helper class, store necessary data in it, and then pass it to a worker thread. A clone data. Off-screen canvas. How does that work? Read transfer handler. I see. So it's a serialization. Is that it? Create from clone data. You like create one from the data. Okay. To clone data. You create this clone data. Custom rate transfer. Structured clone. I see. In the structured clone holder. So we detect whether or not this thing is a special item, like it's a off-screen canvas, and if so, then we set content to that, and that's what gets passed to the other thread. I mean, couldn't we just like have a struct imagine a struct in a world. We have a struct. It's not anything commie, nscom, jump list, Windows jump list. Do we ever use like the dot equals? No. Like imagine a structure, get handler app item in a world where it's just a struct of an app, an icon index, and a favicon page URI. It's like, so it'd be the path, string, like what else do we create? We create jump list item, m handler app, get handler, local handler. We create the args. You just append it. We just append spaces. So it's arguments. A description, app description comes out of mime info local handler app. There's apparently a description. Is that true? Detailed description. Right. String description. What else? Then there's the icon index, which resource index, icon index, which is a long icon index, and then favicon page URI. So we have an NSI URI there. And what happens whenever we get page, we get the icon URI, and then what do we do with it? We just use that to get the icon file. Icon URI. And the reason for that is widget. What in the world? What is this? Exists in the file. Get the file. Get the output path. If the file exists, cache icon. We go and get it with the favicon service. We use the favicon service to get the favicon data. And then what do we do with the data is available? If the favicon does not exist or the cache is expired, this method will be available. I got a feeling none of this works properly too. Favicon data ready. So what does it do? Next time try build a jump list, it'll be available. Service, we go and get it. Then the callback is when it's ready. Sorry. When it's ready on favicon data on complete. It's gonna write it. Oh, okay. That's what happens. So it copies it and writes it to the disk. It pulls it out of the favicon database and writes it to the disk in the profile directory. Is that still what happens? No old IC left and remove icon for all items. Observe, clear private data. Okay, so that's just all removing stuff. Do we ever still write these things? Jump list cache dir. Delete all favicons from disk. Do we ever write? Obtain cached icon file. Call back whenever it's ready. I think we probably do. Async favicon data ready. On favicon data on complete. Yeah, we do write it. We write it to disk. And the reason for all of that is why? Does the caller expect to have Can we not update these things asynchronously? Page UI, ICO file. Fill with a path exists, get its path. Obtain cached icon file. It's because ultimately it's supposed to be a location on the disk. And if we don't have it, we fall back to showing the app icon. Set icon location. Oh boy. Oh boy. So this thing, this PSL, which is a iShell link, we can't. Can we update its? It's expecting the icon to be a file on the disk. Location or set icon location. Sets the location path and index of the icon for the shell link object. The address of a buffer to contain the path of a file containing the icon. Okay. All right, gang. Let's write that down. Is that related? Icon index. When we get the icon, set icon location, we just set it to 0. Our encoded icon only has one resource, so set it to 0. Okay. So it'd be like a string icon path. This is the structure, I think. Which this is a little confusing. Icon index. What's icon index used for again? Set icon location. App icon index. What's done with it? If we don't, that fall. So this is like the fallback icon index in the event that the icon path, we don't have one. If we can't get the path, if that's like the empty string or something, then this will be the fallback, like application icon index. Okay. So if we construct an array of those structures, I think we can do what's necessary to, if we can transfer that to the background thread, we can create our list. And like the API for creating lists, there's this like building and committing, and that's really awkward. I feel like it should be like populate. It'd be like populate jump list, and it'd be like if this is a jump list description, jump list item description. Well, maybe I'll say it's a shortcut description. Jump list shortcut description. Populate a jump list with an array of those things. That's it. That's the API. None of this like other stuff, like what we've got with abort, delete. Well, maybe delete. Might want to be able to clear the list. Setting the app user model ID maybe makes more sense, but this like add list to build and commit list to build, is list committed is gone. I think something like this might make more sense than like promise like clear list or something. Okay. So do we have a nice way of transferring, like creating and transferring stuff like this? So normally, I'm gonna write this down. Normally these days, we don't define. We try not to define. We try not to add more XBCOM. Just like as a rule, as a general rule. So we could, for example, define jump list shortcut description as WebIDL, and because it's basically a dictionary. As a WebIDL dictionary. And then have promise jump list accept an array of those. Do WebIDL dictionaries serialize nicely between threads, across threads? Or transfer nicely across threads? I suspect the answer is yes. Thread info. That's actually interesting. Thread info dictionary. Sexual information. Well, no. But this is like how you define a thread, or like a dictionary in WebIDL. And this would, in theory, be kind of like what we're doing. And like, let's just see one of these things getting created. Create a sequence. Threads. Thread info dictionary. Append out. We create one of these things. We copy the thread info. Copy sysproc info. System info. So this is on the oh, then we move threads. This is, yeah, not on a different thread, I don't think. This is a promise. This is running on a event target for task category performance. Runnables related to performance counting. I think this is still on the main thread. It's just like a lower priority task. Child info. Okay, so I think I'm barking up the wrong tree here. I want to find an example of us like transferring a structure like this. Clone. Like what I want to see is jump list builder. What I want to see, oh no, not in here. What I want to see is something like dispatch, like new runnable being passed. Oh, not in WebIDL, sorry. New runnable being passed, like, wish I could get more context. New runnable method being passed, like some WebIDL structure. I feel like if I were to see that, it'd be probably somewhere in DOM. Script runner. I think that's just basically queue. It's not moving it to a different thread. It's just queuing it for later. Okay. DOM. Dispatch. Just looking, what I'm doing right now is I'm looking at these method names to try and like get a hint on, you know, our media stuff does a lot of off-thread business. Would they? Maybe what I should be looking for is like, yeah, what is an output mute state? Output mute state's an enum. Okay, that's fine. You know what I need to do is maybe ask someone. I think that's what I'm gonna do. I think I need to ask someone. I'm having no luck finding a good example of transferring web IDL dictionaries between threads. I did want to look to see what kind of patterns we have for passing arrays of dictionaries as parameters. How does that work? Whenever you want to pass an array, how do you do that? pass an array to... Quick, anybody, what is... Oh, sequence? Sequence. Yeah, sequence. A sequence of window info dictionary or something. You can pass it a sequence of UTF-8 strings. So it'd be something like populate sequence jump list shortcut description. And it would return a promise. Undefined. That would reject with anything that went wrong. How's that? How's that as our sort of structure here? So now I'm going to ask in developers on Matrix whether or not I'm now going to ask some Gecko experts in developers on Matrix whether or not moving things between threads that are defined as web IDL dictionaries is advisable. Oh, the last thing I want to figure out is whether or not you can just sort of like pass in a JS object as a dictionary. I think you can. Like whenever you have something like the event init, or like dictionary, like places bookmark edition init, is passed to no, that's not what I wanted to. I want to find like a good set of params. Yeah, params. Prio encoder. Perfect. So like if you Prio encoder. Do you have any examples of us in JS? Prio encode, batch ID, Prio params, Prio encode. Ugh, okay. I'm relatively certain you can just pass like a JS object and it will like figure out whether or not what you're passing makes sense. Event init. Like fluent message record. No. What do we often call? Oh, like IOUtils. Perfect. Yeah, IOUtils. If you call read options, so like IOUtils read, it's expecting an optional read options. Read options is a dictionary that has these two properties and inherits from read UTF-8 options. And if I go IOUtils.read, we can see that like sometimes you pass just like a raw object as the second parameter or argument to the function, and it knows, oh, okay, that is one of these things. Like IOUtils, the implementation, is it just IOUtils.cpp? Gets these read options as a constant, and we can like start pulling things out of it. So that's nice. I think that's what I want to do. So I'm gonna have to ask about. Oh wait, hold on a second. IOUtils might be like a perfect example of us transferring things between threads. Do we pull these things out? We transfer the offset to read. It's just a number. Maybe it's sufficient that I just, instead of transferring the description, we just pull these individual parts out. We can definitely transfer strings and longs. So maybe that's just what we do. Wait a second. Why don't I just decompose the jump list shortcut description into its primitives and transfer those? We have plenty of prior art showing us moving strings and longs between threads, right? Like we get path to read is a maybe. We write into to read. We transfer that. Offset is pulled in. That's another thing. File. We're moving NSI file to the other thread. And so maybe NSI file, we can do that. Maybe it's fine because we created it here and we make sure we don't do anything else with it. I think what we can do is we can like read these things out and move them to the other thread. Basically copy them. Basically copy. Which, you know, isn't... Well, can we take ownership of them and move them instead of copying them? That might be better because... No, I think we actually have to copy them. The caller might hold on to a reference. They might, yeah. Well, that I can ask about, but I think we've we're starting to see a plan here, and I think this is going to greatly simplify. What was I doing? This stuff, the add list to build and commit list build, we can get rid of that. We can actually get rid of a lot of stuff. Once we start getting rid of, or once we add this mechanism in, what I would like to do is try to immediately, here, I'm going to add web IDL for jump list shortcut description and add populate jump list method to jump list builder. Effectively, we're doing a rewrite in place. And then once we have that, if we get that working, I think we can start just stripping stuff out. We can just start stripping stuff out once we have that capability. So I apologize. It took us, it's like, once again, it's a long road. Oh, someone pointed out this web IDL bindings, some documentation on web IDL bindings. Transfer thread. The interface and expose network here, global. Need a flag. Use to flag. Need subject principal. Needs no subject principal. Okay. I think I've read the web IDL documentation before. So thank you for the link there. In fact, if people are curious, let me just put a link to that inside of the agenda. Web IDL documentation. Nope. Copy link. There you go. Actually, we can do better than that. We can get a permalink. Actually, we can do better than that and get Firefox source docs and get formatted bindings. Yeah, this stuff. And put that in the agenda. All right, gang. Yeah, that went sideways pretty quickly. But I'm glad we did it. I'm starting to feel like there's real opportunity here to clear out a bunch of old stuff. Like, we've been hacking around in this old part of the code base that kind of has like shag rug and stuff from the 70s and stuff in it. And I think we can, if we can build our better way, and then we can strip all the rest of the stuff down and it can just kind of go away. I think that would be good. It would be helpful if we designed a nice way of testing it. If we're in this state, like the jump list. I'm curious to know what it used to do. Like, I think it's just like ensuring that the XPCOM stuff is actually saving and retrieving. Like, we can write and read from it. And it's doing the right processing. So that testing might be worth thinking about. So think of how figure out how to make the above testable. Whether or not that means having a way to read out what's in the jump list, that might be ultimately what we do here, is we just like read back as a testing function. All right, I think I'm going to call it there. Hey, thank you so much for watching episode 302 of The Joy of Coding. I know that wasn't a lot of writing code, that was more reading code, but hey, that's the name of the game. That happens often. Let me know what you thought. If you enjoyed this episode, there's a rate this episode link at the bottom of the agenda. If you're watching this on Twitch, there's a link down where you saw the agenda link. You can rate this episode. Let me know what you thought. If you have any questions, you can submit them. If this was your first time watching the stream, I hope that was interesting. If you're a long-time viewer or medium or short-term viewer, thanks for coming back, and hopefully I'll see you next week. So have yourselves a great week. And I will talk to you soon. Take care, everybody. Bye-bye.
The joy of coding.
See ya.